Thank you. Well, thanks that you came despite being so close to the long weekend and despite the weather being so horrible. Glad to have you here. My purpose of this talk, or the reason I decided to present something in ACTUM Academy, is not only show you what we are doing in our team with Eliška, Martin, and Peter, who is on holiday. But hopefully to get you excited and get some ideas from you to work together on different improvements on the work we do already. And this is connected to the second part of the title. So what does all this stuff we'll talk about mean for us and meaning us, ACTUM and ACTUM Plus, whether technical people or digital consultants, relationship managers. How can we all somehow get inspired by these tools and put them in our work, and we'll be happy to help you there with what we've done. So my goal today, I will quote one of my currently favorite books about algorithms and data analytics, and it's very simple. So after this talk, I hope you would be able to distinguish AI from BI and BI from BS. And because these are buzzwords, yeah, so like AI, big data, machine learning, deep learning, blah, 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 cloud stuff, yeah? So we need to distinguish what's real and what's not there. And I'm provoking you with this image, and I have a point on that. And the point is that all this machine learning and applying math on the business is not new. It's at least as old as Guinness Brewery itself. So most of the modern, a big chunk of the modern statistic theory was applied on, was discovered during improving processes on brewery. So so the story is more or less this. If you want to do quality control of I don't know, imagine thousands of barrels, you cannot just go and check one by one because this is just crazy, yeah? So you need to sample those from those millions of barrels in a smart way so that you can guarantee that the defects on the sample are going to be close to the defects on the total population with a certain confidence. So instead of opening 30,000 barrels to see that everything is fine, you open, let's say, 3,000 and check that everything is fine there. And then you say, okay, with 95% confidence, I believe that the fault rate is going to be 1%. Yeah. So to do this kind of process, you need to think a bit of how are you really going to measure that, and what does it mean to be close to the real defect rate, and so on. So people started to think about it from very long time. This story goes back to the beginning of the last century, so 19 something, yeah. So it's not something that was invented with Facebook or Google or anything like that. Comes from a very long time, and the loop is basically this: so how to apply the scientific method. So into a business problem, and how from a business problem generate new techniques and ideas that would go again to be applied for the next business problem in the loop. And scientific method doesn't mean anything else than being critical and being having some sort of innate curiosity and hacking mindset, which I believe all of you would have, as I think the vast majority of you are programmers. So you are curious and smart people. So thinking of this way is pretty much, I believe, the way you think in your normal life. So you make observations, think about different questions, formulate hypotheses, test those hypotheses against something, preferably data, and then you decide whether your belief of how things work is sufficiently fundamented or not, and then go back to develop, to abstract something out of that experience, and get ready for the next challenge. So it's really applying this this mindset in a concrete business problem. If you are not of the technical persuasion, maybe I can propose you a maturity model of sorts, which we can divide in 5 stages. And on the stage 1, we collect some data. We gather and prepare it for analysis. Then the stage 2 is when we really start doing analysis. And I call it describe, and this is just about what happened. So you collect data from some business process, let's say the interaction of a user with your website, and then you see what happens. So the user clicked here and here and here and there, yeah? And it's just about combining, aggregating, and visualizing, and not doing go on that. On the third step, diagnose. So we see why such things happen. So why the user got stuck on a particular button? Is it something we did wrong? Is it some default of the measuring system, or is it really an issue that goes deeper? Predict goes a bit ahead of that, so it's not only diagnosing, but also guessing what would be the future. So given the interaction of the user with the website up to now, what's the most likely next action, and how should I be ready, for example, to offer new suitable content or so on. And finally, in the most advanced stage, all this is like automated. So in some way, as I understand so far, for example, Sidecore, the prediction is some sort of rule-based. There's no algorithm, there's no discovery, no automation, no generation of new patterns. But that's something that we would rather expect on somehow the second half of the gray square and the first half of the orange square, to have some algorithm that would infer from your behavior, not only to which persona you belong, but if you belong to another persona we haven't thought of. Yeah, and what kind of tools we use on these stages? Well, if we are talking about describing, it's just purely visualizations and some aggregations that are needed. If we want to diagnose something, for example, for our A/B testing, then we talk a bit more about statistics and more sophisticated math. This is just like sums, averages, and something like that, if I'm not wrong. Multiplication sometimes. And then on the later stages, we're really talking about, let's overuse buzzwords and say it's artificial intelligence. It's math, but we have to sound smart. So these 2 stages really corresponds to using information from the past, from what happened, to make the decisions on the present. And when we would be on the later stages of this maturity path, we will using past information to decide on what's the most likely future based on this past information, and then do a decision right now. So we sneak in the future and to optimize our current behavior. Yeah, and this is what we call proper BI. These 2 stages, and then this is AI in this framework. Okay, but that still doesn't say a lot. Digging a bit deeper on what business intelligence is, and what AI and machine learning are. So in business intelligence, it's like a threefold process. So we need to collect some data. So there's underlying, and I should have emphasized it somehow. There's a business question. We want to solve a problem. We want to identify, for example, which customers are more likely to change to a competitor. A client comes to us, let's say Energy, for saying some example, and we have people that they are changing their contracts, and we don't know why. No, they are switching to the competitor. We don't know why. So they approach us and say, okay, can you tell me who is most likely to churn now and what can I do for them? So we first need to collect data about those clients, aggregate it, and in business intelligence, we're talking about sums, averages, ratios, basic information, and then finally passing to a visualization layer that will, tell what happened. And examples of this in our work is this funny dashboard you've seen if you've passed by or part of the building, this huge TV. This is an old screenshot, but what it shows is how the marketing campaigns for Yacht Charter are performing. So we put all the data together from Google Analytics, from I'm not sure if S-Click is here, and CRM, maybe not in this view, but we pull data from different sources, pull it together in a context that makes sense for the people who understand what this is. That's not my case. I know how to use numbers, but I'm not sure how to interpret it as good as the performance marketing team. And then this tool enables them to make decisions. Another example is this dashboard that we did for a certain pharmaceutical company, which might or not be data. You'll never know. And the objective of this dashboard was to show the people who are developing content for the website how the users react to this content. So again, we pull data from different sources. Eliška does her magic in Tableau, and we are able to provide the business with a tool that they can use to explore and test the hypotheses themselves. And say, for example, whether certain content is more suitable to a certain demographics. They may have their beliefs, like say, okay, I guess that ladies 25, 34 are going to read this, and then they realize it's, I don't know, men in their 40s who are reading those articles. So that might help them to challenge their beliefs, preconceptions, and adjust their behavior. But again, as you see here, there's nothing too fancy in terms of algorithms. It's just putting together data, aggregating it, and giving it a context that makes sense for the business. And to do this kind of work, we use different tools. So we need some ETL engines at some point. So, for example, Teradata, SQL databases. I put Hadoop, but we don't have such big projects yet. But it's the same. It's an engine for data warehousing. Visualization tools, and not much more of more than that, really. But the advantage of having good tools is that we can save time. And we have, for example, this for another client, that they were preparing their reports from Excel spreadsheets, sharing with each other, and then cut and paste stuff on PowerPoint slides. And this was a horrible process, error-prone, that took 2 weeks and 20 hours because it had to circle around the company a lot. When they passed it over to Eliška, she did her magic in Tableau, and she was able to deliver the same results quicker than the client needed. This was for a marketing performance, email performance, campaign performance. So you see, like, if you see the results of your campaign 2 weeks after it happened, this is super bad because you cannot tweak it anymore. There's nothing you can do about it. It's just post-mortem analysis, really. Not much to do. But if you have the right tools and the right technologies, you are able to react much faster and make better decisions. So that's why we have to be selective on our tools. And in terms of tools, there are two popular BI stuff that promise to be like self-service and magic and everything. And the vendor will tell you that you buy one of these and all your problems are going to be solved forever. There are differences between these tools. You've probably heard of Power BI if you are using Microsoft stuff. Power BI is aimed to be a platform for self-service analytics so that you don't need to hire people who understands anything. You could, in principle, do it all yourself. Comes in different flavors. So it's like a desktop, which is like the Visual Studio for Power BI. Yeah, so some development environment, some IDE. Then you can share the reports online, and you can see the dashboards yourself. It's not very fancy in terms of themes and customization and so on, but it does the work, and many companies use it, including us from some point on. And Tableau, which has different, has again like similar set of flavors. So like there's some desktop environment on which you can develop. There's a reader which is free, and you can just see what someone else does. And there are online and server version of it when you can share dashboards like this one, for example. This is a dashboard in Tableau. So, oops. And allows a bit of more of flexible data exploration. So just for a quick note for consultants and relationship managers. So the main difference perhaps for you is that, well, in Power BI, when you share a dashboard made on Power BI desktop, which is free, you share also the data sources which might be enriched, and pretty much tell the client how you did it. Whereas it's not the case in Tableau. You can binarize it and protect the IP. Just a quick note. So this is business intelligence. It's a rather mature area, I would say. There are tools that have been tested and tried forever, and methods and so on. What I want to show you on now is what's really machine learning into all this. So there's 2 points here. So machine learning is the science of getting computers to act in a certain way without being explicitly programmed to do so. Artificial intelligence is any kind of intelligence that can be exhibited by a computer. So in particular, machine learning is a subfield of artificial intelligence. So it's one of the ways in which you can can make a computer seem intelligent. Artificial intelligence is a bit more than that, because machine learning concerns itself with algorithms. Artificial intelligence deals, for example, with computer vision, like how can you teach a computer to recognize pictures or sound or other things. So it's more on that direction, including the algorithms. Yeah? On a machine learning project, process is more or less the same. So there's some data that has to go to an analytics engine, that has to go to a visualization engine. But the difference is that the analytics, the algorithms are a bit more complicated. And we're talking about linear regression, for example, decision trees, optimization, or maybe I believe that many of you have heard of neural networks or deep learning. Yes, another buzzword. Yeah? So different methods that are a bit more sophisticated. I will illustrate some of those in quick examples to not give you an impression that just words were said that don't mean anything. Yeah. Where is machine learning used? And well, first, why it somehow became a thing now? Like, what's everyone talking about machine learning and data and stuff? For one, it became cheaper to store data, and it also became more data started to be generated. So this this kind of exploded when the internet exploded, when people started using Google, when Google realized that storing data was a good idea, when Facebook realized that storing data was a great idea, and they started to build products and services around those data they were collecting from the user interaction, and then it somehow mushroomed to other sectors. So now you see, for example, in financial services, companies are using your details of your phone call patterns to decide if they are going to give you a credit or not. In healthcare and, well, let's say insurance in some way, there are many use cases. One, for example, is to survey automatically the medical literature and try to recommend you a treatment for a given disease. So you have they collect a lot of data points, then they run some model on top of all the articles, and they say, okay, so given the characteristics of this patient, what is the treatment or the combination of treatments most likely to work to heal him? Look, if you reverse engineer it, you think it a bit on the other way, it could be funny, because you could end up in a situation where you would have a recommendation system for your health. So people who have your health status got sick of, so you might be interested in this and this diseases. So, but with the same data, you can do many things. On marketing and sales, well, that's our stuff pretty much. So the recommendation systems, personalization, how to optimize some parameters of a marketing campaign, for example, how to optimize some parts of the sale process to generate more leads, more conversions. Transportation, so it's like around logistics, and you've heard of Uber, for example. They are heavy users of machine learning to this hideous feature of dynamic pricing. And on the energy sector, so there's now also a lot of interest on smart buildings or ways to, for example, in large data centers like in Google, to say, okay, am I able to predict which servers are going to be loaded at which time so that I can shut them off and save money? When Google started using one of the types of machine learning, I'll show you, they managed to save the energy bill by 40%, which is huge if you are talking about Google's data center. Yeah, so 40% saving is kind of noticeable. Yeah, and well, this is like the big four of the machine learning space. So companies that are using massively algorithms and intelligence derived from the data that they collect. Note that two of them are somehow on our industry, so as advertising, media, personalization. Yeah. So, and these are the pioneers really. So I think we are on a good place to become like more machine learning driven than we are so far. Machine learning has like three different phases: supervised learning, unsupervised, and reinforcement learning. And I'll just quickly guide you through them. So supervised learning refers to the following. So you have some variable, some data, and you have a response associated to that data. Think of, for example, images. You have a bunch of images, and you know that they are all cats. So yeah, so you have your independent variables are these images, let's say, and the response is the label, so the type to which these images belong. You can think of comments on Facebook. You have a bunch of text strings, the comments, and for each comment, someone created a label and say, okay, this is a positive comment, a negative comment, and so on. So supervised learning is concerned with, given this setup of the data, creating an algorithm that, given a new example, so if I give you a new image or a new comment, you can tell me what his right level is based on the information you had before. I give you a new comment, you tell me if it's a positive comment or a negative comment. I give you a new image, you tell me if it's a cat or a dog or none of those. Or something in the middle. And how does it work? Well, you have some data. And well, this is not limited to images or text or anything. We can also think of, for example, churn, or product recommendations or something else. When you have transaction data and you want to predict, for example, given the purchase history, who is likely to churn, what's the number of expected transactions in the next month, what's their customer lifetime value, what's the thing they are more likely to buy in the future. And the way this operates more or less is, well, you get some raw data, whether it's text or images or transaction. You create some sort of summaries from it. Once you create your summaries, your pre-processing, you split some part of this data and in what is called a holdout and a validation set. A training and a holdout set. And you create you teach an algorithm given the fraction of the data which is on the training set, find some equations or some method that is able to predict, to guess with a minimum error what's the correct level. And then you test it with the unobserved data and see. So you will have, for example, for each, you have a set of comments that are positive or negative. You leave 80% for training. You create some model on top of that will tell you, okay, the model will be able to decide somehow, it's a black box for you, that a comment is positive or negative. And then you test on the 20% of the comments you set apart. You pass it to this model, and then it will tell you, I believe this comment is positive, I believe this comment is negative. And then, because you have the 20% of the real data, the true levels of the real data, then you can compare how much further you are from the correct answer. And in this example, for using transaction data, for example, we can see that when compared on the testing set, on the holdout set, we can measure our performance. So we create some model that predicts the conditional number of expected purchases or something. Don't worry about it too much. And then we see, okay, so what happened was this black line trend, and what we predicted that will happen was this red line, or similarly here. So we can see one example is in R, I think, and this is Python. We can see, okay, so we observed the blue line, we predicted the green line, so it's not that bad, the trend of those. So we are more or less, not too far from what happened. So we have an engine. We taught the computer without hard coding it, and that's important. So the computer somehow learned by itself to identify the correct patterns, and we can measure how precise that engine is. So that's the story in the quickest introduction to supervised learning in the world. I hope it was understandable. In unsupervised learning, the story is a bit different, because we have no correct labels. So we don't have if you think of the faithful comments example, suppose we're just now giving a bunch of comments, and we don't know if there are positive or negative or anything. So what can we do with that? Yeah, so that's supervised learning. That's unsupervised. And a common scenario in e-commerce, for example, is to try to find segments of customers given the transactional history. And what's a customer segment? Well, a customer segment is just division, a partition of the set of customers into customers that share some similar properties in terms of products purchased or frequency or money spent or something. Yeah. So if we're given just the transaction history, the typical use case would be to identify those segments somehow. And then again, the story is quite similar. We do some summaries, and here it doesn't make too much sense of splitting in training and validation. We just match it, aggregate some data, create some variables from the raw data, and kind of compare them to one another, and define some criteria for being similar. And then you just group the most similar customers together. How does these two look in practice? Well, this is a mock-up dashboard of the customer overview. So here on this axis we have the probability that the customer would churn, and on the vertical axis we have the number of customers. So we pass some transaction data into our models, and we are able to identify, like, okay, there are some customers that are in high risk of churning to the competitor. So this is an example of a supervised learning model. And here we'll say, well, okay, this is somewhat unsupervised learning. This is RFM segmentation for marketing, recency, frequency, monetary. So how much time ago did you buy something? How often, and how much was it in money? And then you can see like different customer segments. So this big blue square, for example, this represents customers with low monetary value in blue that bought over a year ago and that only bought once. So these are horrible people who hate us and will never come back again to us. On the other end, we have people who bought over 3 times, who bought a lot because they are red, and who bought recently between 180 and 270 years. Yeah? So these guys are fine. They like us. We also like them because they buy. And there are some like problem children here. Yeah. So it's not their problem is that they are too much in the past. They could be redder if they try. So maybe we can think of some way to make them more red. Yeah. So offer them some product that is more relevant to them. Make them a discount. See what they purchased before, and then give them a voucher or something. So this is like how we can use this framework in the practice. And the last one, which is in my opinion the most interesting, it's called reinforcement learning. And here the story is a bit more complicated because you don't have data and labels or data, but you have something that changes with time. So you have some states. Let's say I will make it precise in a moment. And for each of these states on which you can be, you can take different actions, and these actions are connected with some reward. And after the reward is allocated, you move on to a next state. And typical example of this is, or a great example of this is Atari. So think of a state as the screen, yeah, of your Atari game. And the action is this is Pong, so you pass the ball from end to end. Your action is to go up or to go down, and your reward is here, the points you can make. And the challenge here is to come with algorithms, to come up with algorithms that would be able to play well Atari without being hard-coded. And show you a demo. So you have here in so you have One of them is the artificial intelligence, like hard-coded by the programmers, the Atari programmers. And the other one is an algorithm that is learning, that learned from playing a lot of Atari by himself. He captured the state of the frame. He captures like 4 frames, put them together, and creates some score. And he learns to play. So which one do you think is the algorithm? And which one do you think is the original algorithm with the Atari?
Algorithm is the green one.
The algorithm, yeah, of course. I wouldn't put my picture next to it if it was not the green one, right? Yeah, so the green one became quite proficient, and it's able to beat at beyond human level performance in Atari games. Yeah, so it's quite.
It is the cycle. It is.
Sorry.
Still the same way.
Yeah, the video is not.
It is like the GIF turn it again and again because the
yeah,
green is winning all the same fashion.
Because I guess this is hard. Okay. Yeah, this if it's hard coded, it has to have like very simple rules, no? Because you are not going to program it all yourself. I mean, so maybe it was easy to infer it.
The green found the glitch.
The green found the way around this one. Yeah. So so this is an example of reinforcement learning. So you have state, actions, up, down, rewards connected to it. But it's not about computer playing only. So we can. There are actually more serious scenarios, and something that is not visible in Pong, but you can see in other video games. For example, if you play the Prince of Persia, you know that, or Mario Bros, you have to do certain actions that and then at some point, whether you did or not those actions, where you collect some weapon or something, you can kill the monster or not. So there are some actions along the way that you would have taken and that are connected with a reward, but it's not clear from the beginning, like whether I got the reward thanks to the action 2 or action 1 or action 3 or where. And this is also a reinforcement learning problem. And it's if that sounds very abstract, that's something that you would be familiar with if you are a marketer. So this is attribution modeling. So which of the different touch points can be credited with a purchase a customer makes? And that's the same problem. That's the same problem from the mathematical point of view than playing Atari. You would have never believed that. I should have asked you at the beginning what are the similarities between Atari and Google Analytics. But well, I think I told you the answer. And this is also something we did for Jakub Huri's team. Success fee report, which is called like position based. So using the reward that comes in the future, in this case the reward is if the customer did a purchase or not, which of the different channels should be credited with that, yeah? And what we use to do all this, well, is the same tools as before in some way. So there's some data preparation layer, some visualization, some programming for the modeling, and what I think is the most important, so some knowledge of math, but especially hacking mindset and curiosity. So people who are like naturally asking themselves questions that have a yes, I can do it mindset. This is like the combination of these things what makes all that happen. Okay, and just to conclude my talk and give you some time before the .NET marathon. Well, so what does this mean for us? What all this stuff mean for us as ACTUM Plus companies? Well, it means that if we believe the Deloitte Consumer Review report, that we are not going to be out of work anytime soon. More and more people are interested in personalized services. Like 20% of those customers who want personalized services, which are, I think, it's around 60% on that survey, 20% are willing to pay up to 20% more. So it's not only they want them, but they want them like an awful lot. Yeah, and 22% of customers are willing to share their data, and they don't mind too much if the service, the personalized service, is really good. Yeah, so I sometimes get a bit disappointed from when I get some generic email, no, because it's like, come on, I gave you my Facebook login. Can you just look there what I like, and why do you offer me quinoa? No, it doesn't make sense. Yeah. Please use my data. And I think I'm not the only one, apparently. However, there's still some. I mean, this number is not as high as it could be, perhaps, because there's more and more customer concern about data privacy and who is going to use my my data, and what are you exactly going to do about it. So the customer kind of wants to eat their cake and have it at the same time. Yeah, so you want more personalized services without having to give you my data, which is a bit tricky. Nonetheless, might be possible. In our team, what we are developing, what we've developed as POC was dashboards and different use cases for customer analytics, product analytics, and marketing. I've presented it already to many of you. Would be happy to share details individually if you're interested. For each of these, provide them different aggregation views for different people on the company who would use them. And these are, for example, like this dashboard I quickly showed you before, or this other mock-up for Power BI for analyzing purchasing patterns on a e-commerce website, a shop that sells some baking products or something. And we have more things on the way. We are working, for example, on how to verify that an email address is correct, and how to get as much information as possible from it. For example, to be able to identify the names or other data. We've seen some German services that Jan is using via API, and we're asking ourselves, well, maybe this is not that hard. It's something probably we can do ourselves to collect those data internally without having to pay for the API calls. Another long-term ongoing work we're doing is around attribution modeling and performance marketing for Jakob's team. So they want to see, like, in real time what their marketing campaigns are doing, and how to ideally tweak them to incentivize some behavior of their customers. We will help finance guys with their Power BI report. So we'll have our mini Power BI deployment soon internally. And more important, I think we would like to be able to use data from Sitecore and Kentico to develop algorithms, prototypes, and so on. One first idea we have in mind is to measure the effectiveness of personalization. That's something we are not sure has been done at all. So how to prove the customer with hard evidence that personalization works, that generates more revenue or happier customers or more puppies on the world or whatever. Yeah, and this is some with the help, of course, of Gianluca and Peter Shivny, which is not here, I think. And yeah, we very much like to be able, for example, in the case of Sindulka, because it would really help us to understand how Kentico works and what we can build and we can do about around it. So if any of you Kentico experts in the room would like to have a chat with me afterwards, I will be more than happy. And we can agree on maybe next steps. Well, this email and falls somehow in the collect and describe stages of the maturity model I pictured before, and the others are a bit more ahead. I think we as a company are somewhere maybe here between the yellow and the gray, but as Michal says, you know, it's you need to be just a bit ahead of the clients, and then you can still be able to help them. Yeah, we cannot help people who are clients that are here, but we can help all the others. And at the same time, we will be moving ahead on the diagram. And well, just to close. So what are the implications of this wave of interest of machine learning and data collection and so on for us as humans, not as regardless of whether we are Actum or Actum Plus or not. And one thing is that well, data can be misused, and it's somehow also of our interest. Yeah, so can end up in situations that are not pleasant because of your data shoots back on you. And plus things that can go wrong is models that are wrong that are doing wrong policy decisions affecting people. For example, a model that would be taking into account racial profile, and none of the experts of the modeling experts saw that this was a big mistake, that the model was using race information to decide if give a loan to a person or not, then this is something to be worried about. Automation, but this is going on since the 19th century. People are afraid that machines will take the work out of you. So what if the robot it's fine to have an algorithm playing Atari, but it's not so fine doing that the algorithm is doing your job and you are out of work. That's not so good. Concerns about privacy. You do something wrong on the internet and you are done forever. And that now became an issue is that ethical treatment of artificial intelligence algorithms. Yeah, so whether the guy who was playing Pong is capable of sentience, and whether we should, whether we have the right to disconnect him because he's somehow exhibiting human-like features. So that's maybe way too futuristic, but anyway, those are issues that we will be hearing a lot about in the future, and that's all from my side. Thanks. Don't know if you have questions, comments.
I have a question about the supervised learning. I know that there is a way currently to misrepresent, to fake an image. I believe it's the same with the text. Is it possible to do the same with the text? When, for example, we show an image of a monkey, but the machine understands that it's in a cat. Is there a way how to avoid these fake images and to understand that this is not a cat?
It depends how good the algorithm is trained. How it works for images is that you.
Well, it's simple changing of the pixels on the key places. Probably, I'm not aware, but I suppose it's.
But where have you seen this?
Well, I read a lot about this that changing some pixels make machine understand that the image is the actual image of the monkey, elephant, whatever, crocodile. But in the reality, it should be like the image of the cat. So the machine understands it's an image of the cat, but in reality, it's crocodile.
How it works is that so to do some image recognition, you like take the image and divide it in small parts, and you do like some sort of statistics on the small cells, and then once the machine learns what is the correct combination of color intensities or so of catness, whatever that means, then when it recognizes catness somewhere else, then it will assign it. But the way to make the abstraction is to change the algorithm, to throw in more data. So in this case, for example, and that's called that's how it's done in healthcare. No? So when the machine is not sure that some image is of a tumor, then it's passed over to a human expert, and then the human expert says, like, yeah, okay, so now this is actually not a tumor. That's okay. Then you click on something, then it's recorded on the database, and then in the evening or something, the algorithm runs again on the batch and updates from the learning. But there's no like automated way. On some of the first experiments they did on the 70s, they reported like a huge success because the machine was able to recognize cars, I think, but like different brands of cars or cars from trailers or something like that. Then they found out that what the machine was actually doing is identifying whether it was day or night, because all of the car pictures were on the day and all of the trailers were in the night. so there's not much of carness that the machine learned. So you have not really no control on what it is. It depends on putting more and more images. What you can do to avoid this kind of abstraction is from an image, to generate a bunch more that are slightly modified. So the computer would learn like different degrees of catness at some point.
Okay.
Yeah. More questions?